Today we're going to take a look at section 5.1, which is about finding the derivatives of natural log functions. Okay, so we're going to have u be some function, a differentiable function, meaning you can find the derivative of it with respect to x. I'll explain what that means in a moment. Okay, part A is our straightforward definition, and this comes from the limit definition of a derivative. We're not going to go through that process for this particular type of function. We're just going to add this rule to our list of derivative rules. So the derivative of ln x is equal to 1 over x. Plain and simple. That's all there is to it. Okay, so the derivative of ln u with respect to x, that means we're looking at something like natural log of 2x minus 7, or natural log of x squared plus 3. We have some function on the inside. So this is a u and this is a u. Okay, so it's a function that we can easily find the derivative of it. Okay, so this is really just a generalized chain rule type problem. We have an inside, which is the u, and we have an outside, the natural log. So this is our chain rule. So we change the outside. So we do 1 over the inside piece times the derivative of the inside piece. Okay. So we change the outside. The outside is the natural log. The derivative of natural log is 1 over the inside thing. Okay. And then we do times the derivative of the inside function, du dx. Another way to write this is 1 over u times u prime, or you could also write it as u prime over u. Keep in mind that's u prime, that is not u to the first power. So we're going to go through a couple different examples to see how this really works out, and they're progressively going to get harder as we go, but we're going to start with two that are on the easier side of things. Okay. So problem number 1. We have y equals the natural log of x cubed. Now there are two ways to do this, and I'm going to show you both of them. All right. First one is we think of this as the natural log of x cubed. So that means the natural log is on the outside, the x cubed is the inside. So it's like saying that u is equal to x cubed. So you want to think about it in terms of 1 over u times the derivative of u. So that would be 1 over u is x cubed times the derivative of x cubed, which is 3x squared. And we know that that can simplify. If I write this as 3x squared over x cubed, or u prime over u, that can reduce down to 3 over x. So that's our derivative. Okay, so that's one way to do it. So that's the chain rule way to do it. Now there is an alternative. We could say, well, we have properties of logs that allow us to relocate that exponent. So we could actually use a property of log to say that if we have y equals natural log of x cubed, we can say by properties of logs that exponent out inside can be pulled out as a coefficient, and this is really y equals 3 times the natural log of x. Okay, now it looks like we've done a derivative because you're thinking power rule, but really we've just applied the properties of exponents to expand the expression. We have not done any calculus yet, and this is why notation is important. This is still y equals, not y prime equals. So now if I want to start finding the derivative here, I don't really have an inside function anymore, I just have an x on the inside. So this is back to the first rule. When there's a constant out in front, that constant stays put, and then we multiply by the derivative of the other function. So we're going to have 3 times the derivative of ln x is just 1 over x. So here we also get dy dx, or y prime if you prefer, is equal to 3 over x. So it doesn't matter which way you go about it, if you want to do it the chain rule way, like we did in green, or if you want to do the property of log expansion that we did in orange, and then just do the straightforward part A rule. Either way, you're going to get to a final derivative of being 3 over x. Okay, let's take a look at another example with a polynomial inside, and then we'll look at how properties of logs can be a lot more helpful to us. Okay. Problem number 2, we have f of x equals the natural log of x cubed plus 2x minus 1. Now, there is no property of log that can be used to expand this. I have a sum of different terms on the inside, but there's no exponent that applies to this whole thing. There's no product or quotient involved. So this is one of those problems where we have to treat it as natural log of u, where the u is equal to x cubed plus 2x minus 1. Okay, so the derivative of natural log of u, again, is 1 over u times u prime, or you can also think of it as u prime over u. So what that means is we're going to go ahead and say our derivative, so f prime of x is equal to 1 over the inside function unchanged, which is x cubed plus 2x minus 1. And then we're going to multiply by the derivative of that inside function. The derivative of x cubed plus 2x minus 1 is 3x squared plus 2. All right? And then as far as simplifying this goes, you just want to get it down to a single rational expression. So just put that 3x squared plus 2 in the numerator. And then the denominator will stay the x cubed plus 2x minus 1. This doesn't reduce at all, so this is our final answer. So that is the derivative of natural log of x cubed plus 2x minus 1.